Okay, good morning, students. Are you able to see the screen and can you hear me?
Yes, ma'am.
Yes, ma'am.
Yes. Okay. So, good morning once again, and so we'll start the session. I hope you remember what we have discussed in the previous class. So, in the context-free grammar, we have tried to simplify the context-free grammar by doing some substitutions and transformations. So there are four such transformations we have seen. The first one is substitution rule, and then the second one is substitution rule. Second one is removal of useless productions. And the third one is removal of lambda productions. And the fourth one is removal of unit productions. I hope you would have noted down these things in your notebook. So yesterday we have discussed about the first two things, substitution rule and removal of useless productions. So today we will start with the third one, that is removal of lambda productions. Is it visible or is it very small? Do I need to write it big?
Yes, ma'am.
Removal of lambda productions. So this is what we are going to discuss today. So first you just write down this definition. So so what we are doing with this simplification is we are trying to remove certain undesirable productions, right? So in that case, we have removed some of the useless productions. And so today, one such undesirable production is that on the right hand side, having an empty string. Okay, on the right hand side of the production, having an empty string is one such undesirable production. So we want to remove such production from the context-free grammar. Okay. So you can take down the definition. Any production of a context-free grammar of the form A gives lambda is called lambda production. Okay, we call such productions as lambda production. So if you have simply an empty string or lambda on the right hand side of your production is called as a lambda production. And also, so this kind of productions we will be able to find it easily because lambda is explicitly present on the right hand side. Okay. Apart from this, any variable, you take down this also, any variable for which the derivation A derives lambda on arbitrary number of steps is possible is called nullable variable. Okay, so what does this mean? One is you will have a production exactly of this form. Okay, on the right hand side you will be having only the lambda or the empty string, so that you can identify this as a lambda production. Okay, and apart from this, if you have a variable which on arbitrary number of steps. So we used to, in a given grammar, we used to derive, and in multiple steps we derive and we'll get some string, right? So on such derivation, if you are able to find, if you are generating a lambda, okay, so initially it may not be lambda, but after some derivation steps, if you are able to generate a lambda, then that variable is called a nullable variable. Is that clear? So we are going to identify such nullable variables and lambda productions, and we are going to remove it. So you consider this particular example. Yes gives A S1B, and S1 gives A S1B or lambda. Okay, and this particular grammar is for the language L is equal to A power n, B power n, such that n is greater than or equal to 1. Okay, so there is a grammar S gives A S1B and S1 gives A S1B or lambda. And this grammar is for the language L is equal to A power n, B power n, such that n is greater than or equal to 1. So actually, if you look into this language, the language generates the strings like AB or AABB, okay, so on. And there is no, if you see that there is no lambda included in this language, okay, there is no lambda in this language. But still, if you see the grammar, we have a lambda included in the production. Okay, so even though the language generated by this grammar does not have any string lambda, still it is the grammar is having a lambda production. Okay, so this is not needed actually. So we want to generate a equivalent grammar. Okay, we want to generate a equivalent grammar by removing the lambda production. Okay, equivalent grammar we want to generate by removing lambda production. So what we can do is, so here we have S1 gives lambda. So to remove this lambda production, what we can do is, we want to generate some new productions by applying this lambda wherever S1 is present. Okay, we are going to generate some new productions by applying lambda in the place of S1 wherever it is available. Okay, so then what are the new productions we can found? S gives, so if you apply lambda to this S1, you will be generating AB. Okay, we will be generating AB. And again in this production, if you apply, we will be again getting AB. Okay, so these are some new productions we are generating by applying S1 gives lambda. Okay, now we can include these productions into your actual grammar by removing this lambda. Okay, so by substituting this lambda only, we are generating this new productions. So now what we can do is, we can remove this lambda and add these new productions to your grammar. Okay, so now the equivalent grammar will be S gives A S1B. Okay, this production is already available. Along with that, we have generated another new production, that is AB. Similarly, S1 gives A S1B, and another new production we have generated, that is AB, and lambda can be now removed. Okay, by substituting lambda only we were able to generate these new productions. So now after removing lambda, and we can add these new productions and we can remove the lambda production. Okay, so now this grammar, this equivalent grammar will be now able to generate the same language. Okay, is that clear? So what is lambda production? We'll be able to easily identify a lambda production by looking at the production. Okay, if lambda is present on the right hand side of the production, it is called lambda production. And apart from this, there are some other variables that will generate lambda after some derivation steps. After some arbitrary number of derivation steps, you will be able to generate a lambda. So such variables we call it as nullable variable. Okay, so these nullable variable and this lambda productions, we want to remove it. Okay, so so we can do that by applying lambda to the place wherever that variable is present. Here S1 derives lambda. S1 gives lambda. So wherever S1 comes, we apply lambda and generate new productions. Okay, and then add that to the original grammar, so that you will be getting an equivalent grammar for your original grammar after removing lambda production. Is that clear? So this is the about removing the lambda production. So we will quickly do one problem on this. I hope you have written all these things.
Ma'am, can you tell that example again? I didn't understood.
This example.
Yes, ma'am.
See, we want to remove this lambda production. Okay, so you cannot simply remove that lambda production from the grammar. Okay, so before removing this lambda, so why this lambda is used in this grammar actually? You can see here, the language that it is generating is a power n, b power n. Okay, so for example, you start from the start variable. S derives A S1 B. Okay, so if I want to generate this string AB, and I can apply lambda for that, right? I can apply lambda to this S1 so that I will get AB. Okay, or else A S1B, and now I want to generate AABB. Okay, then what will I do? So once more I will apply S1 gives A S1 B at this place. So A for S1, I'll apply this A S1 B followed by B. Okay, now what is required? AABB. So already I have got AABB. So in the place of S1, if I apply lambda, I'll be able to get this string. Okay, so to terminate the derivation, we are using the lambda in this grammar. Okay, so now I want to remove this lambda production. So if I want to remove this lambda production, then equivalently some other production has to be added into this grammar. Okay, only then you will be able to generate whatever you require for this language. See, for example, so this is the equivalent grammar we have generated, right? So this is the equivalent grammar we have generated. Now you try with this new grammar to try to get this language. Okay, so you can see here, if I want to generate AB, then directly I'll be getting this. S derives AB, that's all. Okay, we have a production say AB, so directly I'll be able to get it. And if I want to get AABB, then S derives A S1B. Okay, and what is needed? AABB. I have already one A and one B. So in between I need another AB. So what I can do, instead of S1, I can apply AB. So A, AB, B. Okay. So what we are doing here is, while you are removing lambda production, you are generating some equivalent production for that, and you are adding it to the grammar. Is that clear? Are you able to understand it now? So how you are generating the new grammar, new production? The grammar given, the production given is S1 gives lambda. Okay. So in the place of wherever S1 comes in the right hand side of the production, you apply lambda. When you apply lambda, what happens? That vanishes. Okay, that variable vanishes, and you will get the remaining thing. Okay. So if you are applying lambda to the first production, S gives A, S1, B, what you will get? You will be getting a new production. S gives AB. Okay. So before removing the lambda, we are generating new productions. Okay, equivalent to that lambda value. Okay, here lambda is used as a terminating condition. Wherever you want to terminate the derivation, we are using the lambda, right? So, but here that is not at all necessary. Now this becomes the terminating condition, terminating symbols. Okay. So first let me apply lambda to this S1, so that I am getting S gives AB. And so this is one new production. And again, if I apply lambda to this S1, we'll be getting S1 gives AB. Okay. So before removing lambda, I'm generating two new productions. Now these two productions, you can include it in the grammar. Okay. So that is why we have this production, it will remain as it is. S gives AS1B. Along with that, we are adding this new production that belongs to variable S. S gives AB. So we are adding one more production, this new production to the equivalent grammar. Similarly, for S1, already we have A, S1, B, and now we have generated a new production for S1. So that I am including here. Okay. So that by adding these two new productions to the grammar, I am removing this lambda from the grammar. Is that clear?
Yes, ma'am.
Yes. So quickly we'll solve one more problem related to this. Then we'll move on to unit production. So please take down the problem. S gives A, capital B, small a, capital C, and A gives capital B, capital C, B gives D or lambda, and C gives capital D or lambda, and capital D gives small d. Okay, so this is the problem given. So now we want to identify the lambda production as well as the nullable variables. So now by looking at the problem itself, can you identify the lambda productions? Can you please respond? What are the lambda productions here?
B and C.
Yes, very good. So B and C are the lambda productions here. And now one more thing I told you about the nullable variable. Okay, so these two are explicitly seen. Okay, because we have lambda on the right hand side of the production, so we were able to say that B and C are lambda productions. So B and C are nullable variables. So apart from this, by applying this nullable variable to any other variable, if you are able to generate lambda, then that also will be a nullable variable. Okay. So for example, here B and C are lambda productions. Okay. That is, so you can just put it in a set like nullable variables, Vn. Okay. So in this set, now we have B and C. Okay, these two variables are now nullable variables. So now you need to check by applying these nullable variables or by applying lambda to other variables, whether you are able to generate lambda for any other variable. For example, if you are applying lambda to this S production, okay, yes, we are having S gives A, B, A, C. So if you are applying B and C lambda, then again you will be getting AA. So that will not become lambda. Okay, anyway, that will not become lambda on the whole. But when you come to A, okay, what is this A production? A gives BC. Okay, A derives BC, and if you are going to, so both B and C are nullable variables, or they are lambda productions. So if you are applying lambda for both of this, then this will become lambda. Are you able to understand this? Okay, A by itself is not a lambda production. Okay, A by itself is not a lambda production, but since B and C are nullable variables, they are lambda productions. When you apply lambda to this production, it derives lambda. That is what we have seen. A on arbitrary number of steps, if it is able to derive lambda, then A is again a nullable variable. So that means now A is also a nullable variable. So the first step before removing lambda production is that first you need to identify what are the lambda productions. Okay. So if this is a lambda production, then these two variables are nullable variables. Apart from this, by applying this, if you are able to get some other variable as lambda, if some other variable is able to generate lambda, then that is also a nullable variable. Is that clear? So now we want to remove this lambda production. So how can we remove that? One second, just a second. Okay, so we will now we have found which are all the nullable variables. So A, B, and C are nullable variables. So now how we can remove the lambda production is that what we have done in the previous example. So we are going to apply lambda to all these variables wherever it is coming in the right hand side. Okay, so in all possible ways we have to apply it. So for example, in the first production we have S gives AB AC. So this is the original production. You don't change this, you write as it is. Okay, the original production you write as it is. Now we have A, B, C, all these three variables are nullable variables. Okay, so what we are going to do is we are going to apply lambda to these variables in different possibilities. Okay, so for example, the first I'm going to apply lambda only to A. Okay, I'm going to apply lambda only to A. So if I apply lambda to A, then that means A will be vanished. What I'm getting will be B, A, C. Okay, and the next new production so we are going to generate new productions like what we have done in the previous example. Before removing lambda, we want to generate equivalent new productions, and then only we will be able to remove the lambda production. Okay, so we are now generating new production by applying lambda to these variables. Okay, in all possible ways. So the first possibility is I am applying lambda only to A. Okay, by applying only lambda to A, I am getting a new production BAC. Okay, so next one I am applying lambda only to B because B is also a nullable variable. When I apply lambda only to B, what I will get? I'll get A capital C. Okay, this is another new production I am generating. And then now C is also a nullable variable. So I am applying lambda only to C. So what will I get? A, B, small a. Okay. So now I have applied lambda individually to A, B and C, and I have generated 3 new productions. Now again continue this with other different possibilities. Now let me apply for both A and B. Okay, two variables combine and apply and see. So if I apply lambda to both A and B, then what I will get? AC. Okay, and another possibility. So now I have applied AB. Next, let me apply for BC. Okay, both B and C are nullable variables. If I apply for B and C, what will I get? After applying for B and C, I will be getting capital A and small a. Okay, so B will be lambda, C will be lambda, so remaining is AA. Okay, now so we have applied for AB, then BC. Now another possibility is AC. Okay, if I apply lambda to A and C together, then what I will get? BA. Okay, if I am applying lambda to A and C, then what we will get is BA. So another new production. Now, so first we have applied to each individual variable, then we have combined it to two variables in all possible ways, AB, BC and AC. Okay, now we can have all 3 variables. So now we can apply lambda to all 3 variables together, A, B and C. So that what you will get? A. Okay, suppose, so for example, if you have the thing as ABC, okay, if you have something as ABC, okay, so if you are going to apply all 3 variables lambda, what will you generate again? What will you generate? Give me the answer. If suppose there is a production something like this, ABC, okay, and since all these 3 are nullable variables, if I'm going to apply lambda to all 3 together, what will I generate?
Lambda.
Lambda. Okay, so this is the only exception while applying lambda. So our purpose is to remove lambda. Okay, so again you should not generate lambda. Okay, so if such cases arises, then you need not apply it together. Okay, because it is not our purpose to generate another new lambda production. We want to remove the lambda production. So if such cases arises, then you need to avoid generating another new lambda production for that. Okay, so now this is the production we have ABAC. Now we have found the nullable variables as ABC. So in all the productions, we are going to apply lambda for these nullable variables one by one, and we are going to generate new productions. So as we generate new productions, then only we will be able to remove this lambda from the grammar. So for the first production, we have completed it, okay, by applying lambda in different possibilities. The next one is A gives BC. So this is the original production that you write as it is. And what is the new production that we are going to generate? If you are going to apply lambda for B, then you will be getting C. Okay, if you apply lambda for B, then you will be getting only C. And if you are going to apply lambda for C, then you will get B. Okay, so now that case arises. Okay, what I told you just before. Now if you are going to apply, because both are nullable variables, so first these 2 productions are generated by applying separately. First you have applied for B alone and you got a new production C. Then you applied only for C and you got B. now if you are going to apply for both the variables, what happens? It will again generate a new lambda production, so that we can avoid it. Okay, so now in this case you need not apply for both the variables, because that will again generate another new variable. And so now, because we have added all the new productions, so there is no more B and C, A, B, C on the remaining productions anywhere. Okay, only in the first two production we have these nullable variables on the right hand side. So we have applied lambda for that in various possibilities, and we have generated new productions. The remaining things, so now the lambda can be removed. Okay, now the lambda production can be removed because already we have generated the new productions equivalent to that. So the lambda production for B and C can be now removed. Okay, so this is the equivalent grammar that we have generated by removing the lambda production. Is that clear? Yes or no? Okay, I need some response in the chat box. Everyone has to respond, whether you understand it or not. Kindly give some response in the chat box, whether everyone understood this or not. Okay. So now we'll move on to the next transformation, that is unit production. Okay, removal of unit production. I hope you are all taking down it in your notebook. Kindly take down in your notebook. That will very much helpful in your examination. So the next one is removal of unit production. So what is this unit production is about, and how we have to remove it? So just make a note of this definition. Any production of a context-free grammar of the form A gives B, where A and B both belongs to variables, is called a unit production. So from the name itself you can understand unit is a single, okay, is a single one. So on the right hand side of the production, if you have only a single variable, okay, only a single variable on the right hand side of the production, then we can call it as a unit production. Okay, so now we want to remove such a production also, and so we'll go with an example and I'll tell you how to do that. Take down this example. So let us take this example. So before solving this one, let me tell you how to. So in the previous example, previous thing, by removing lambda production, we have seen that we need to generate new production. Okay, before removing the lambda production. The same is the case here also. So what are all the what are all the unit productions available here? Can you see? What are all the unit productions? Can you put in the chat box, or can you unmute and tell? This is the form of unit production. A gives B. On the right hand side, you should have only a single variable. So that means S gives B, that is one production, which is a unit 1, and B gives A is a unit production, and here A gives B is a unit production. Okay, so these are the unit productions. So now before removing this unit production from the grammar, we need to generate equivalent new productions and add it to the grammar. Okay, so that is what the concept is. So now for doing that, what we can do is, here we can use the substitution rule. Okay, we can very well use the substitution rule to do that. But what happens is, sometimes it makes a round off. Okay, so sometimes you will be having both A gives B and B gives A. In that case, what happens? All the B production you will replace here, again all the A production you will replace here. So there will not be any solution ultimately. Okay, so the purpose will not be solved. Again, you will be getting unit production. Okay, so to remove that, what we are going to do is, we are going to have a dependency graph for the unit production. We are going to have a dependency graph for the unit productions. So what are the unit productions we are having? S gives B, and here we have B gives A, and one more thing, we have A gives B. Okay, so these are the unit productions we have. So for this unit production, we are going to draw the dependency graph. So what are the nodes we are having? S, A, and B. So what is the dependency here? S is giving B. Okay, there is a dependency between S and B. And then B to A. And then A to B. Okay, so this is the dependency graph we are drawing for this particular grammar. Now from the dependency graph, what we are able to perceive is, you can see that from S you will be able to derive A. Okay, on arbitrary number of steps. Okay, when I put this arrow mark and above that a star, it means that arbitrary number of steps. That means you derive something, derive on after some steps, you were able to derive this. That is the meaning. Okay, so yes, on arbitrary number of steps, it is able to generate A. Okay, there is a path going from S to B and then from B to A. So you will be able to generate A, and also you will be able to generate B. And what are the other paths available? B to A, and then A to B. Okay, so first, before removing the unit production, what we have to do is identify all the unit productions, draw the dependency graph for that. Okay, from the dependency graph, you write down all the paths or the walks available between each node. Okay, so from S, there is a walk to B, and also there is a walk to A. Okay, from S you will be able to reach A also, and from S you will be able to reach B, and from A you will be able to reach B, and from B you will be able to reach A. Okay, so write down these things and make it as equation 1. Okay, now based on this only, we are going to remove the unit production by substituting the corresponding non-unit productions. Okay, so we will see that. So okay, until this you please copy down, okay, or else I'll continue it here. So now what we want to do is, we want to, so this is the actual grammar. Okay, this is the given grammar or the given set of productions. So let this set of productions be P, capital P. Now we want to generate a new set of productions. Okay, we want to generate a new set of production. Let us call it as P cap. Okay, we want to generate a new set of production. So let us call it as P cap. So now the first step is in P cap. First, you include all the non-unit productions. Okay, so first include all non-unit productions. Okay, all the non-unit productions we can include it here. So let me write the problem once again here so that you will be able to see that S gives AA or capital B and B gives A or small b, BB, and A gives A or BC or capital B. Okay, so this is the actual grammar, actual set of productions. So from this, only the non-unit productions we are first including in the new grammar productions. Okay, so what are the non-unit productions? S gives AA, okay, and then B gives BB, and then A gives A or BC. Okay, these are all non-unit productions. So unit productions are this B, A and B are all unit productions. So first include all the non-unit productions. S gives AA and B gives BB and A gives A or BC. Okay. So now what we have to do to remove this unit production, we want to generate some new productions, right? We want to generate the new productions. So how we can do that? We have generated an equation 1 which are all having walk between different nodes. Okay, by looking at the dependency graph, we have come up with the set of nodes that are having walk between each of the nodes. From S we will be able to reach B, from S we will be able to reach A, then A to B, and from B to A. Okay, so we have a set of equations here. Now based on this, we are able to generate new productions. Okay, so what could be the new production is, so S derives A. Okay, so that means for S, we are going to add the productions of A. Is that clear? We are going to substitute. So for A, what are all the productions we have? That we are going to include it to S. Because S is able to derive A. So what is the A production we are having here? Okay, these are all the non-unit productions already we have written. So what is or if you are okay, you can directly write it. You will not be confused. Please just listen. So these are all the non-unit productions already we have added to the new grammar PCAP. Okay, new set of productions PCAP. So now we want to, by satisfying this, we are going to add new productions. So what is this given? S derives A. So for A, what are all the productions you have? We are going to add it to S. For A, what are the productions we are having? A or BC. Okay, so add that to S production. Is that clear? Do you have any doubt in this?
No, ma'am.
Yes. The next one, S derives B. Okay, so that means the productions of B can be added to S. Okay, the productions of B can be substituted to, it can be added to S. So what is the productions we have for B? BB. Okay, so this can be added to the S production. Okay, so now that is over. Now the next one, B derives A. So that means the productions of A can be added to B. What is the productions of A? A or B. So this can be added to B. Okay, and finally A derives B. So that means the productions of B can be added to A. So productions of B are now BB, A or BC, but A or BC is already there in A. So the new thing, only thing is BB. Okay. So now we have satisfied all these equations and we have generated new productions. Now if you see this new set of productions, you can see that there is no unit production. So automatically the unit productions were removed by adding the new productions. Okay. So now only thing that we are getting here is the first one we have seen removal of useless productions, right? So you can see here from S, B cannot be reachable at all. The variable B is not reachable from S at all. So B become a useless production. So we can remove this particular production along with this. Wherever B comes, this B productions can be removed. Okay. But for removing unit production, this will be the answer. So if you want to proceed by still simplifying, by removing the useless production, we can remove this production. Okay. So this is what removing unit production is. So I'll give you one problem because time is up. So I'll give you one example problem where you should remove all the lambda production, unit production, as well as the useless production. So while you are doing that, please note down the order in which you have to remove. Okay, order in which you have to remove this lambda, unit, and useless. So first remove lambda production. Okay, first remove lambda production followed by unit production. Please note down this order. So when a problem is given, all these combinations may be there. There may be lambda production, there may be unit production, there may be useless variables. So how we have to simplify the context-free grammar is, first you need to remove the lambda production. So after removing lambda production, you will get some set of productions. From that, you have to remove the unit production. Then again, you will get a set of production. From that, you again remove the useless productions or the useless variables. Okay. So in that, you will be using the substitution rule. So the mainly you have to remove lambda, unit, and useless production. So I'll give you one problem for homework. So I'll upload the link for this in GCR. After completing this homework problem, you please submit it in GCR. Okay. So take down this problem. S gives A capital A or A capital B, and then A gives A capital A and lambda. B gives BB or BB capital C, and C gives capital B. Okay, so this is the homework problem where you remove lambda production, unit production, as well as useless production, and finally bring out the simplified context-free grammar. Okay, is that clear? So kindly give your attendance in the chat box. Put your register number in the chat box, and then you can leave the class. If you have any doubt, you can ask. Otherwise, you can put your register number in the chat box and you can leave the class. Thank you, students.
Ma'am, please show that question.
Yeah.
Thank you, ma'am.
Yeah, thank you, Ma. Thank you.